Hey guys, this is Math 116, Section 6.2, Compound Interest and Geometric Sequences. So remember in Section 6.1 we had simple interest and arithmetic sequences. Now we have compound interest and geometric sequences. What's the difference? Your brain is exploding. I can hear it from here. Well, happily for you, the main difference is in the compound interest questions, you'll see the word compounded. So if there's no compounded, you're dealing with simple interest, or it might say simple interest. So let the question alert you to what type of interest you are looking at. So in general, though, compound interest is different from simple interest because the interest as you go along is adding to your principal, and you are also earning interest on the interest. What? Okay, let's just look at this example. Question number 11. What are the future value and interest earned if $3,200 is invested for 5 years at 8% compounded quarterly? Okay, this word right here tips you off that you are dealing with a compound interest question. So here's the formula you're going to use. Periodic compounding. So again, look at this. It says compounded quarterly. So that every 4 months, your bank account, in theory, stops. They put the interest onto your bank account, and now the interest will also be getting interest, which is a good deal for you. So it's compounded quarterly. This means periodic compounding. So quarterly, every 3 months, they're going to stop. And add the interest. Here is the formula. Future value equals S, Superman's not from the future, equals principal times, this is 1 plus the interest rate raised to the n, or I would stick with this part of the formula right here. I'll highlight that. Principal times 1 plus r divided by m raised to the mt. You're not really going to want to memorize this. You're going to want to write this down. P is principal. That's how much money you put in initially. R is the annual interest rate. And M is the number of times you are compounding per year. So I'm going to show you what this problem looks like. This is question number 11. So we had $3,200 you're putting in. So our P, our principal, is $3,200. And we're saying we're investing for 5 years. This is question number 11. I just read it to you. So T is equal to 5 years. And in this case, we are compounding quarterly. Compounding quarterly, that means every 4 times a year. Compounding quarterly. So M, that's the number of times you're compounding per year, equals 4, and R is the annual interest rate, which is 0.08. So all of this was in the problem. I'm going to back. Okay, so here's the formula. We need a P, an R, M, and T. Principal, the annual rate, the number of times a year you're compounding, and how many years. So here's the information again. $3,200, this is the principal. 5 years. 8%, that's the annual interest rate, and compounded quarterly, so that means M equals 4. All right, back to the problem. Here we go. Now we're just going to use this formula. So the formula is S is equal to P times 1 plus R divided by M raised to the M times T. So in this case, it's 3,200 times 1 plus R is 0.08. This is a lot of plug and chug. M is 4. Just plugging it into a formula. M up here, 4 times, this dot is times 5. So all of this becomes $3,200 times this whole piece here. If you plug this into your calculator, start on the inside and then raise it all to the 20th, is going to be, that's 3,200 times 1.485947 approximately. So this answer is about 4,755.03. So the simple interest, S, future value. Future value. So at the end of your 5 years, you're going to have $4,755.03. That's the future value. And again, what happened here with your problem is you had $3,200. It's growing along at this interest rate of 0.08, And then at the end of the first 4-month period, they add the interest on, so you have the $3,200 plus some interest, and now all of that is getting the interest rate, so etc. Sort of like that. So just worry about these formulas. You don't need to worry about, you know, what's happening on a monthly basis. So this is the future value, but I believe that the question said, what is the future value and the interest earned? Do you see? Interest earned. So let's go to this page. So we had S is equal to the future value was 4755.03. So the interest, and we knew our principal was $3,200. This is still question number 11. So we want to know, how much interest did you make? Well, we started with $3,200, and at the end of 5 years, you had $4,700. So the interest is going to be equal to the future value minus the principal. That's always the formula, by the way, which is 4755.03 minus 3,200. So the interest earned equals $1,555.03. That's pretty good. I mean, you put in $3,200, you got $1,500 back in interest. I like it. Okay, here's the next question. There's periodic compounding. We just did that. Question 19. What is the compound interest if $410, so now you just start with 410, but you're putting it away for 10 years. Good for you. You're just going to leave it alone at 8% compounded continuously. So in this case, you'll notice it's compounded continuously. It's constantly adding, as opposed to being compounded every 3 months, compounding quarterly. So compounding continuously. This is your red flag to use this formula. And this is page 383, the continuous compounding formula. It's right here, and you're definitely going to want to write this one also on your card. Future value, S, for continuous compounding is P, principal, times E, that's E is the rate, the exponential, raised to the RT, where P is your principal, T is years, and R is the annual rate. Let's look at a problem using this one. Oh, it was this one. Question 19. What is the compound interest? $410, 10 years, 8% compounded continuously. So here's how we're going to use it. Here's question number, oops, my pen is too skinny. There, 19. Question number 19. We have P, our principal, is $410. T, our time, is equal to 10 years. In these, it's always in terms of years. And R is the annual interest rate is 0.08. So this one is compounding continuously. It's just constantly adding to itself. The future value, S, future value, is P times E, exponent to the RT. So this is going to be $410 times E raised to the 0.08 times 10. That's 410. You're going to want to do this on your calculator. That'll give you something like 2.22541, you know, approximately. So all that equals $912.47. I put a little dot there, meaning it's about that. So the future value is approximately $912. Remember, you started with 410, you waited 10 years, and you got 912 out. That's not bad. And it said, what is the compound interest? So we don't actually want the future value, we want the interest. Why do we want the interest? Because we want to know how much we made. So again, you're seeing the pattern. Interest equals the future value, S, minus the principal. So in the future, we had $912 minus the 410 that we started with, means our interest was $502.47. That's pretty good. You got more interest than you put into it, right? You only put 410, you got $502 in interest, but you had to wait 10 years. So that was a very patient proposition. Question number 51. So now we're moving into geometric sequences. So the reason compounding works is because it is snowballing. Your money, if you put it away and it's continuously compounding, you're earning interest on your interest. So you get this snowball effect, which is called a geometric sequence. So question 51 says write an expression that gives the 13th term of the geometric sequence with the first term 10 and the common ratio 2. So here's the formula you want to use. This is nth term of a geometric sequence. It is a to the n, and again that's the notation for the nth term is equal to a to the 1, the first term, times this r, which is the common ratio. It's not a rate, it's the common ratio, raised to the n minus 1. And the book has a nice picture. You can consider this like a snowball of money. Snowball of money. Do you see it? I think people would build more snowmen if they were made of money. So here's question number 51. Write the geometric sequence. So here's what we're thinking. Here's what they're talking about. It's different from an arithmetic sequence. 51. So we want the 13th term of a geometric sequence. Okay, red flag. It says geometric. It does not say arithmetic. It says geometric sequence. First term is 10. And the second term, or common ratio, sorry, common, that word is common, ratio is 2. So this is what the geometric sequence is doing. We start over here with 10. And then in the arithmetic sequence, we always added the same distance, but now we're going to use a common ratio. So the common ratio is 2. So we're multiplying this by 2. So what's 10 times 2? Well, that's 20. So this is the first term. This is the second term. Okay, so according to the geometric sequence, I'm just showing you how this works. This is not how you're going to actually do the problem. We're going to multiply that by 2. Ah, we got 40. Okay, the next one's going to be 80. So second, third, fourth. Right, what's the fifth sequence going to be? Well, it's going to be 80 times 2. So that's 160. So you'll notice the distance between this one and this one is 10. The distance between this one and this one is 20. So it's not the same distance, but it's the same ratio. You're multiplying each one by 2. So it's a geometric sequence. It's not an arithmetic sequence. This is like that game, that app called 2048. You know, you add 80 and 80 and you get 160. Anyway, as an aside. So here's using the formula. It is a to the n equals, go back to this picture, a to the 1 times r to the n minus 1. A to the 1, r to the n minus 1. In this case, a to the 1 is equal, that's the first term, is 10. The ratio is 2. And we're interested in n is the 13th term. N is 13. Now we plug it into the formula. The 13th term in the sequence is going to be the first term, 10, times the common ratio, 2, raised to the 13 minus 1. It's going to be 10 times 2 raised to the 12th. So 2 to the 12th. 2 to the 12th. It's hard to say. And the answer to that is 40,960. And if you were a patient person, you could keep going and you would find that if you carried this geometric sequence out, you would get 40,960. So again, the reason we study geometric sequences in this section is because your money with compounding continuously is doing this geometric sequence of snowballing, essentially. But the main thing I want you to keep in mind for these is I want you to be familiar and be able to use these formulas. Periodic compounding, continuous compounding, right, this one, that's continuous compounding, and then the geometric sequence. So if you have these 3 formulas down from this section, you should be able to work your way through the quiz and the questions on the practice test and the final. Give it a shot.